Incoming transmission from Adventure Corp. This is Alex once again. Are you guys enjoying your ride on the way home? So far, it looks like you guys haven't hit anything too serious yet. So it looks like the debris system avoidance systems that we're building are currently, luckily, not necessary to be used quite yet. But let's make sure we finish that system as soon as possible before you get to the few sectors from now where we end up, obviously we're going to be needing it.
Hello, I'm Chris, this is Gross Models, and welcome to day 27 of 30 Days Lost in Space. We're near the end now, so yeah. Today is another day when we're not actually going to be building anything. This is all about coding once again, so this is all, forget about that for now. Don't worry about that. The code today is much the same as yesterday, but even more complicated. So I understand even less than I did yesterday because, yeah. I'll go through it as well because, again, going through it helps me learn some of it, maybe. And obviously, that's what this video is all about. So, yeah. So we're including the libraries as we did before. This is all the same as yesterday and setting up the keypad that we still haven't plugged in yet anyway. Yeah, setting everything up. That's exactly the same as it was. Then we are... I think we did all that. This was the masks for the different things and firing and ships and destroying. Defined all of the different possibilities of different trash and player character spaceship type files, how they're going to move, if they're going to be hit, when they're going to be destroyed, everything else there. Right, I think we did that. We're setting up the size of the screen and where things are going to be displayed on it. We definitely did all of this, the object types that we were setting up. Right, I don't think we did this, the list of the objects on screen. Basically, we're counting how many objects they're going to be, depending on the difficulty level and how many asteroids and things appear. I think we did all that. This is the bitmaps that we did before for setting up the shape and the graphics, basically. Right, forward definitions. This is new, and this I don't understand in the slightest. Basically, it's again setting up definitions that we're going to be using in the programming, but I don't understand any of it. The R&D, which a random. Oh, I didn't want to move things about. I don't know what I'm doing. We're creating a random thing, which is down here again. I'll get to that when I get to that. Yeah, new object. No inline. I really do not understand a word of that, and it's sort of brushed over in the video rather than explained. But if you know programming, then you probably know exactly what it's going to do. This is initializing new trash at the coordinates. It's telling you where things are going to be. Yeah, that's that. Utility functions, again, no idea at all. We're setting up the character I as 11 and then looping it through while it's greater than 1. Then we're taking 1 off of it. It's to do with moving things around on the screen, I'm sure, but I don't know exactly how or why. I don't know what a buff is. I don't even recall what the percentage sign does in this programming language. It might just be a percentage. I don't know. Right, here we are returning a random number. When we're calling the function strnd, we're returning a random number. This is used in various bits of the code to decide if something is going to appear, where it's going to appear, and the direction it's going to be traveling in if it's space junk. So something's got to appear at some point on the right hand side of the screen, but we don't know whereabouts. Well, we don't even know if it's going to appear. It randomly will appear or not, because obviously if it's all pre-scripted, then you just learn what buttons to press. So randomly a piece of debris will appear at some point along the side, and it will be going in a random direction, which is all created by using random numbers. So there we go. For the specified index number, return the object. So for the object, get object, we're returning objects plus object number. We're adding one to the object number every time an object appears, because otherwise you lose track of how many objects there are. If it's a missile-like object, if it can destroy something else, again, we're getting the missile mask. If the object we create is a missile, we need to make sure it's got the properties of a missile. That's exactly the same, isn't it? Check if this is a missile-like object. That is, can the object destroy something else? Check if this is a missile-like object. That is, can the object destroy something else? That's a duplicate line. No, yes. Read at ST object types. That looks like we've doubled that for some reason. I don't know why that would be. I assume that's an error. But that, no, that is different. This is a different length. So that's 8T, ST, get missile mask. Oh, that's get hit mask. So it doesn't mean missile like. It basically, if it's going to destroy, if it's going to hit something, then it needs the hit mask. Rather than just the missile mask. Right. Search for an empty object. Basically, if the object is off screen, then we can get rid of it, because we don't need to worry about processing power for things that you can't see. Deleting all objects is, again, when the game finishes, you need to get rid of everything before you can, take game over or whatever. Yeah, so that's that. Counting objects of the provided type, so we're checking to see how many of each object we've got, so we don't get dozens of, asteroids and no walls, or loads of walls and no asteroids. It balances things out a little bit, I think. Calculate the pixel coordinates of the reference point of an object, returns the X value. So it's working out where an object is and making sure the software knows where the object is, because where it's different knowing where it is and showing where it is. It's got to know the coordinates have to be known by the system and actually projected onto the screen by the system. You can't do one without the other. There's not much point. You'd have invisible objects hitting you. The bounding box is what I would know from playing games as the hitbox. Basically, it's the area around the object that counts as being hit. Now, you notice that the ship and that are created in a square box, although they're basically triangular. What this means is that if you get hit on the edge there, it still counts as a hit, although technically your ship isn't shown as being there. In theory, you could make it exactly the right by creating several different hitboxes and making them exactly fit the graphics, but that's very intensive, and for the sake of this game, if it's that close, then it's hit you anyway. So we're making boxes rectangular to make it easier. Clip box with the view window, so we're just basically only showing it if it's inside the window. If it's not on screen, it doesn't need a hitbox, because this is all graphic. If return functions to do that, by the looks of it, it's returning, checking the box. If it's 0, if it's else, it's this, and yeah. Universal member functions. Don't know. It's again to do with the box. Area width, area height. It must just be to make sure it's on screen. Disappear is again to get rid of it if it's not on screen, I think. Type dependent member functions. For every object that we've got, it needs a slightly different function. So for moving, it needs to do this. For disappearing, again, is that. Voids for the draw box. Yeah, I don't understand any of that. Setting the draw color, which again, there's only one color, so that's all it needs to do. Not in use, but apparently we need to do something there. Again, calculating the clip box. And then we have the draw section. Right, yes, to draw each and everything. If you're drawing player 1, it's telling it what object it is, a bit about player 1. I don't know what the variables are there. That'll be 175. It's got to be location. Player 1, 7.5. That must be where it's being put. 7.8 is going up there, and 7.11 is going the other side. So yeah. For drawing the gadget, again, it's being shown where it's going to be drawn. This is dog set pixel. I've got no idea what that does. Again, it's setting up for being able to draw things on the display. And then we've got lots of if case break and things. If something happened, if NR is greater or equal to 0, we've got to set the player. It's find objects, so we're finding where the object is. New trash area. Yeah, if it's destroyed to dust, we need to do this. If it's destroyed in big trash, it needs to do this. If the player's destroyed, we need to do this and change the state end, and yeah, or the gadgets can be destroyed as well. Checking to see if the target has been hit. Again, it's to do with the masks and the hitbox, no doubt. Yeah, hitbox. There we go. Is it in the hitbox? Do any of the hitboxes interact with each other? Because if they clash over each other, then that's a hit. So yeah, update all fire counters. Yeah, fire delay, so you can't just spam the fire button. Fire setup, auto fire. Oh, auto fire, that'd be quite cool. It's not 0, then it's just going to keep firing. Yes, so there we go. That's all of that. More things there. Select init functions. Yet new gadget. It's showing where it's going to be and what it's going to do, and directions for it. Init for the trash. Init for the new trash dust. The walls. So basically, when we call new player missile in the code, it will just go to this bit and run that and be done, rather than having to put that in every time. New player trash creation, showing how much distance for the new ones and difficulty levels. It depends on how much they are, how fast they move, I should think. Dealt with trash. That is. And down the bottom here, we've got the void the normal void setup and void loop are still empty because we haven't done any actual programming yet. All of this is just setting it up, and it blows my mind how complex this is for what this is. A tiny little screen that's going to have little one color pixel graphics that are going to basically just let you move up and down and shoot things at stuff coming from the screen. And how complex the programming is for that. And then you think how, new games that come out today, massive 3D worlds that you can interact with and do things with, just how complex the coding has got to be. It gives me a new appreciation for how games have been getting bigger, the file size and everything else. And now I know why. Because there's so much coding for just a little thing like this. This is the sort of thing that you'd have as a loading game. On a game, while it's loading the rest of the game, you could play this in the background, and this is the programming for that. It astounds me. So that was day 27. Day 28 will be continuing more, and then day 29 should be finished and done. I think 28 we're going to get the screen hooked up. 29 we're going to get the keyboard hooked up to the controls, and then day 30 when we hopefully make it home, and probably got another quiz to see that I've learned absolutely nothing this week because it's been so far above my head. It's unreal. But I'm enjoying it, and I think I'm learning a little bit. I'm not learning as much as I would hope to, but we're getting there. So thank you for watching today. Join me tomorrow when we might get to actually see something and do some physical stuff that I'm better at than I am the mental stuff. So thank you very much. I shall see you soon. Alex will sign us out, and I'll see you tomorrow.
Further ado, this has been Alex, and I'm out. I will see you guys tomorrow, and we will finally get the OLED display showing everything that I've been hyping up until this moment. Thank you very much.